is hybrid parameters or H parameters. These are hybrid, that is the H parameters. Students, you know this, the hybrid parameters are widely used in electronic circuits, especially in constructing models for transistors. Mainly for to analyze the different models of the transistors, we can use the hybrid parameters, that is the H parameters. In this case, voltage of the input port and the current of the output port are expressed in terms of the current of the input port and the voltage of the output port. That means V1 I2 is represented in terms of I1 V2. This is voltage of the input port and current of the output port. This is the current of the input port and voltage of the output port. One subscription is the input and that is a subscript. Whatever the two subscript is there, that is nothing but output port. One subscript is the input port and two indicate the output port. That means we are representing V1 I2 in terms of I1 V2. This is V1 I2 is which parameters? Dependent parameters. Yeah, these are the dependent, and this I1 V2 is which one? It is the independent parameters. Independent. But point to remember, for passive network, H21 is always negative since I2 is negative in this case. How this I2 is negative, I already discussed. During short circuit, the current direction will be changes. That's why it is I2 is negative. Here, I'm not considering any negative here. Here, I'm not consider. That's the reason why automatically we can get H21 is always negative. H21 is always negative. Then how we can write this V1 equal to H11 I1 plus H12 V2. Then what is I2 equal to, students? I2 equal to H21 I1 plus H22 V2. H22 V2. Now, how to calculate this hybrid parameters? Yes, a determination of H parameters. A determination of H parameters. H parameters. Determination and names is also important, students. Then first one is that I given V1. V1 equal to H11 I1 plus H12 V2. V1 I2 in terms of I1 V2. Okay. Now how to define the H11 from this one? Where H11 equal to V1 by I1 at V2 equal to 0. Then what is the name of H11, students? This is the input impedance or input. This is the input impedance, a driving point impedance, input driving point impedance or input impedance. Input impedance with which port is short circuited? With output port is short circuited. With output, it is not a transfer because it is defined only for 1 and 1 only, or 2 and 2. Then there is no transfer from one port. There is no transfer from one port to another port like this. But both are defined at same port only. Input impedance with output port is short circuited. Short circuited. Then how to define H12? This H12 equal to V1 by V2 at I1 equal to 0. Then what is the name of this parameter? This H11 units is, what is the units of H11? Ohms, because it's the impedance. What the H12? H12 equal to V1 by V2. Now tell me, it's a reverse voltage ratio or gain? It's a reverse voltage gain. Reverse voltage gain with input port is open circuited. With input port is open circuit. Then what are the units of H12 students? No units. It is a ratio of same quantity. Both are voltages. Then one more equation is I2 equal to H21 I1. Yes, I2 equal to H21 I1 plus H22 V2. Now from this, what is the H21 students? H21 equal to I2 by I1 with V2 equal to 0. Then what is the name of this parameter? H21 is what is the name? It is the forward current gain or current ratio. Forward current gain. This is the forward current gain with output port is short circuited. With output port. Understand students? With output port is short circuited. Then finally is H22 parameters. What are the units of this one? No units. H12 and H21 is no units. Then last one is H22. How to calculate H22 students? This is I2 by V2, which is 0, I1 is 0. Then what is the name of H22? This is output admittance. Output admittance. With input port is open circuited. Students, if the input port is open circuit, then what are the units of this one? What are the units of H22? H11 units is ohm, H22 units is mho. The units of H22 is mho. Okay, like this we can calculate the H parameters. Like this we can calculate the H parameters. Yes, friends, what is the equivalent circuit of two-port network? Equivalent circuit of two-port network. Two-port network in terms of H parameters. This is also important for competitive point of view. What is the equivalent circuit of two-port network in terms of H parameters? Yes, this is H11 I1, H11 I1 plus H12 V2. H12 V2 is the voltage. H12 no units, V2 is the voltage. That's why H12 V2 is the voltage source. Next, H22 V2 or H21 I1. H21 I1. H21 is no units, into I1 means current. H21 no units, into I1 means that gives the current. And H22 V2. This is H12 V2. This is H22. This is V2. And this is I2. Then what this one? H21 I1. And this is V1. Then how write V1 equal to, students, H11 I1 plus H12 V2. From this, what is I2 equal to? V1 I2 in terms of I1 V2. H21 I1 plus H22 V2. That is satisfied. This is about the equivalent circuit of two-port network in terms of H parameters. Then after simplifying this one, again we are getting the same equations or not. You can check this one. Clear, students? This is the calculation of H parameters or hybrid parameters. These parameters are used for modeling of transistors. Next, inverse hybrid parameters. That is the G parameters. inverse hybrid, or it is also called G parameters. The hybrid parameters and inverse hybrid parameters are dual of each other like Z and Y. That's why G equal to H inverse. Then these are represented I1 V2. This is represented I1 E2 as a function of V1 I2. As a function of V1 I2. That is, these are the dependent parameters and these are the independent parameters. Independent. Okay. This is I1 V2 in terms of V1 I2. All these are the G parameters. For passive network, G12, like H12 is always negative. Here G12 is always negative. I1 is a negative in this case. Then how to write the I1 equal to, students? I1 equal to G11 V1 plus G12 I2. Then what is V2 equal to? G21 V1 plus G22 I2. Okay, these are the inverse hybrid parameters. Then determination of G parameters. The determination of G parameters. Then how to determine the G parameters? Yes, the first one is I1 equal to G11 V1 G12 I2. Yes, friends. Then from this, what the G11? G11 equal to I1 by V1 at I2 equal to 0. Then what the name of G11, students? The name of G11 is input admittance. This is input admittance with output port open circuited. Port is open circuit. Next, what is the G12? This G12 equal to I1 by I2, which is 0 at V1 equal to 0. Then what is the name of G12? It's a reverse current gain. Reverse current gain. With input port short circuit. Next, one more equation is which one, students? I1 V2. V2 equal to G21 V1 plus G22 I2. Is it correct? G21 V1 plus G22 I2. Then from this, what the G21? G21 equal to V2 by V1 with I2 equal to 0. Then what the name of G21? Forward voltage gain or ratio. Voltage gain with output port open circuit. Open circuit. The last one is G22. What the G22, students? V2 by I2 at V1 equal to 0. Then what the name of G22? Output impedance. This is the output impedance with input port short circuited. The input port is short circuited. Students, this is the determination of the G parameters or inverse H parameters. G parameters are inverse H parameters. Then what is the equivalent circuit of two port network? Equivalent circuit of two port network. In terms of G parameters. Yes, exactly inverse, reverse of that H parameters equivalent circuit, reverse of that H parameter equivalent circuit. Yes, just a minute. Yes, friends, exactly reverse of this circuit because this is the H parameters. Then we can reverse this combination. Then we can get the G parameter because it's the inverse. Then what the equivalent circuit we can get? This is a G11 V1. It is multiplied with voltage means it is a parallel branch. And G12 I2. G12 is not having any units, no units. That's the reason why into I2. G12 no units into I2 means that is the current. That is a G12 I2. Next, G21 V1. G21 is no units, but into V1 means that indicate the voltage. G21 V1. Then G22 I2. G22 I2 into I2 means series parameter. It is multiplied with current, that is a series parameter. It is multiplied with voltage, then that is a parallel branch you can represent. So this is the V2 and this is the V1. This current is I1 and this current is I2. Then how to write V1 equal to, sorry, I1 equal to, yes, how to write I1 students? I1 equal to G11 I1 plus what this gives? G11 V1, not I1. Parallel branch, no? It is a G11 V1 plus G12 I2. Here V2, how to write V2? G21 V1 plus G22 I2. Like this. By simplifying this, we are getting same equations. Okay, this is the equivalent circuit of two-port network in terms of the G parameters. Yes, friends, this is about what are the different types of parameters. This is what the units. The units of this parameter is mho. What are the units of this one? G1 to no units. Then what about this also? No units. Then what are the units of G22? This is in ohms. Okay. With this knowledge, in a in terms of different types of two-port network parameters, how to find the condition for reciprocity, condition for symmetry, that I want to discuss. If any two-port network is given, in that network, how to analyze the condition for symmetry and condition for reciprocity. First, we will see the how to check the condition for reciprocity in a two-port network. A two-port network is said to be reciprocal if the ratio of the excitation to response, that is a reciprocity theorem. If the ratio of the excitation to response is invariant to interchange of the position of the excitation and the response in the network. That means even though excitation and response is interchanged, the ratio of excitation to the response remains same. Then we can say that that network is the which one? Reciprocal network. Then we can find the condition. Networks contain resistors, inductors, and capacitors are generally reciprocal. That I told already. Always all the passive networks are the reciprocal. The networks containing resistors, inductors, and capacitors are the passive elements. That's why that network is the reciprocal. Networks that additionally have dependent sources are generally non-reciprocal. If it is consist of generally dependent sources, then it is a non-reciprocal. Now, for example, this is the two-port network. This network, how to check is a reciprocal or not? It's very simple. First, connect the source at input port, and this is the actually it is a port current. The input port is connected with the source. the output port is short circuited. Now for this I1 current, now the current is I2 dash. Because the short circuited, the current is flowing like this. Now you find the what is the Vs by I2 dash ratio. Vs by I2 dash ratio. Now what you can do? Now connect the source at the output port. Now the current at input port is I1 dash. Now you find the ratio of Vs by I1 dash. Now if in this case what I am finding, find Vs by I2 dash ratio. In this case what you want to find? Find Vs by I1 dash ratio. If Vs by I2 dash equal to Vs by I1 dash, that is I2 dash equal to I1 dash, then the network is which one? Reciprocal. If this condition is satisfied, then only the network is reciprocal. If Vs by I2 dash is equal to Vs by I1 dash, here in this network, this is the excitation, this is the response. In this network, this is the excitation and this is the response. That is, even though response and excitation is interchanged, the ratio of excitation to response remains same. This is the ratio of excitation to response. It is also ratio of excitation to respond. These two must be equal. Then we can say that that network is the reciprocal. Then how to check the condition for symmetry? One point I already given students. It's a symmetrical or asymmetrical network. If you see from the input port and if you see from the output port, the network remains same. The appearance of the network remains same. Then it is nothing but a symmetrical. Otherwise, it is asymmetrical. That is one simple networks we can analyze like that. But then we can also analyze the symmetry conditions. A two-port network is said to be symmetrical if the ports can be interchanged without changing the port voltage and currents. For example, for input port, I connected voltage source, the output port is open circuited, then I calculated Vs by I1. Next, what I am doing, now the output port is connected with Vs voltage, the output port is open circuited, the input port is open circuited, then I calculated. In this case, I calculated Vs by I1. In this case, I calculated Vs by I2. Then if Vs by I1 equal Vs by I2, sir, then what is the difference between these two, sir? Here the ports are short circuited, but here the ports are open circuited. Then Vs by I1 equal Vs by I2, then we can say that the network is the symmetrical network. Otherwise, the network is the asymmetrical network. Okay, this is the condition for symmetry. How to check the condition for symmetry in a given two-port network, and how to check the condition for reciprocity in a given two-port network. Clear, friends? Any doubt? Is it okay? Yes. Now, with respect to parameters, this is very, very important for computer exams. In all the computer exam, based on this tabular column, already questions are framed. I'm not giving any derivation, not required, students. For Z parameters, what are the condition for, with respect to Z parameters, what are the condition for reciprocity? If Z12 equal Z21, what are the condition for symmetry? Z11 equal Z22. With respect to Y parameters, what are the condition for reciprocity? What are the condition for symmetry? With respect to ABCD parameters, what are the condition for reciprocity? What are the condition for symmetry? With respect to inverse ABCD parameters, the condition for reciprocity and symmetry. With respect to H parameters, what are the condition for reciprocity? What are the condition for symmetry? With respect to G parameters, what are the condition for reciprocity and what are the condition for symmetry? Yeah, this is very important, students, in all the competitive point of view. Yes, please concentrate that tabular column. It is very, very important, 5-star. Clear, students? These are the condition and reciprocity, condition for reciprocity and condition for symmetry in terms of different types of parameters of two-port network. Okay, this is about how to find the symmetry and reciprocity for a given two-port network. The next very important topic, interconnection of the two-port networks. Interconnection of two-port networks. Yes, please concentrate. Two-port networks may be interconnected in various configurations. We can connect in various configurations such as series, parallel, cascade, series, parallel, parallel series. For each configuration, certain set of parameters may be more useful than other to describe the network. That means the two-port networks are connected either series or parallel connection, series parallel or parallel series. But for each connection, we can use the particular set of parameters only. Because if you use that parameters in that network, then realization, that is, we can easily analyze the parameter. We can easily analyze the network by using that combination. For example, if it is a series connection or it is also called series connection. What do you mean by series connection? Input port is series connection, output port also series connection, or simply it is called series connection. Then in this type of connection, which parameters we can use? Z parameters we can use. Once we can use the Z parameters, those parameters we can add directly, then analysis becomes very simple. That is the meaning. Understand? For each connection, we can use some parameters. Why we are preferring that parameters? If you use that parameters only, that analysis becomes very simple. That is the reason. Understand, friends? That's why series connection means input port is series connection, output port also series connection, or simply it is called series connection. Then which parameters are preferable? Z parameters. In that network series connection, Z parameters are added directly. Parallel connection, or simply it is a parallel connection. Then which parameters are preferable? Y parameters. In that we can add directly Y parameters in parallel connection. If the networks are parallel connection, then which one is preferable? Y parameters. We can use the Y parameter to analyze the network. Cascade connection or tandem connection, we can use the ABCD parameters or T parameters. Then we can directly multiply, not its addition. You please correct this one. Then this is not the addition. This is the multiplication. Then T equal TA into TB. Series parallel connection, H parameters are preferable because we can directly add the H parameters. Parallel series connection, G parameters are preferable because we can add directly G parameters. Very important. In series connection, which parameter? Z parameter. Parallel connection, Y parameters. Cascade or tandem connection, ABCD parameters. Series parallel, H parameters. Parallel series, G parameters are preferable. If you use like this, then the analysis of the network is very simple. In a cascade, in a interconnection of the two-port networks. Clear, friends? Please concentrate. Now we'll see, sir, what exactly series connection, parallel connection, all these. Okay, this is the series connection or series connection. Let's consider two two-port networks. And this is the network A and network B. See, the input port is connected series. This is the input port of the network A and the input port of the network B. These two are connected in series. At output side also, output port of the network B, the output port of the network B is all network A and network B is connected series. That's why it is called series connection. Input port is series connection, the output port also series connection. That's why it is a series connection. Now for network A, I am writing the matrix for network A. We know that Z parameters. Why I am using Z parameters? In this network, if you use the Z parameters, then we can add directly. Then analysis becomes very simple. That is the reason. Then for network A, I am writing Z parameters. We know that Z parameters are represented voltages in terms of the currents. Then V1A, V2A. V1A, voltage at port A and voltage at input port, voltage at output port. V1A and V2A equal to, then Z11A, Z12A, Z21A, Z22A, I1A and I2A. This is the input port. Because of series connection, currents are equal, voltages are divided, then that voltages are added. Because input port is a series connection, that's why I1 equal to I1A equal to I1B. Because of the series connection, current is remain same. But voltages are divided, the total voltage equal sum of the voltages. Then for network B, V1B equal to V2, V1B, V2B equal to Z11B, Z12B, Z21B, Z22B, I1B and I2B. Then even in at output port also, the currents are equal because of the series connection. In parallel connection, voltages are added. Now, the matrix form of the Z parameters of the series connected combination. Then what the total Z parameter? I am writing V1, V2 equal Z11, Z12, Z21, Z22, I1, I2. Now I want to calculate Z11, Z12, Z21, Z22. Then how to calculate? This Z11, Z12, Z21, Z22 equal to sum of these one, students. No need of any derivation. Sum of the network A parameters and sum of the network B parameters. Then these are the Z11, Z12, Z21 and Z22 are simply the Z matrix equal to ZA plus ZB. Okay, this is the ZA, students. Okay, this matrix is the ZA. What is the ZA matrix? This is the ZA matrix. Then what is this matrix? This matrix is the ZB matrix. Then in series connection, the Z parameters are added directly. Clear, friends? Then the result may be generalized for any number of two-port networks connected, not only for only two networks, for any number of networks also. Then the resultant Z matrix equal to ZA plus ZB plus some so on plus Zn. Yes, right. For any type, for any number of networks, not only two networks, for any number of networks also this is valid. The overall Z parameter matrix of series connected two-port network is simply the sum of the Z parameters matrix of each individual two-port network connected in series. Understand? That is the resultant Z matrix equal to sum of the individual Z matrix. Sum of the individual Z matrix. Okay, this is about the interconnection of the two-port networks with respect to Z parameter. Series or series connection is preferable. Next, parallel connection. Sir, what do you mean by parallel or parallel connection? Input port is parallel connection, output port also parallel connection. Then parallel connection means voltages are equal, but currents are added. Here, even output port also parallel connection, voltages are equal, but currents are added. Let this is for network A. This is for network A. This is for network B. Then resultant Y matrix is this one. Then what is Y11, Y12, Y21, Y22? Okay, this is Y11, Y12, Y2. That is the resultant Y matrix equal to sum of the individual Y matrix. Sum of the individual Y matrix. That means in parallel connection or parallel connection, Y parameters are added directly. This result may be generalized for any number of two-port networks connected in parallel. The overall Y parameter matrix of parallel connected two-port network is simply the sum of the Y parameter matrix of each individual two-port network connected in parallel. Okay, that is the meaning. Okay, this is the matrix YA matrix and this is the YB matrix. Okay, this is the matrix representation of the Y parameters. Then resultant Y parameters equal to sum of the individual Y parameters. Then in parallel connection, Y parameters are added directly. Clear, friends? Any doubt? Come on. Respond.
Say,
Voice. Now okay.
okay, sir.
Sorry. Yeah. This I1 equal to I1A, V1 equal to V1A, minus I2A equal to I1B. These two voltages are equal because this combination and this combination, these two voltages are equal and these two are series combination. Yeah, that's why these currents are equal here. Because whatever the output voltage is there, that voltage and here you are applied. Then what about this relation? I2B equal to I2B equal to minus I2B equal to minus I2 means then we can write I2B equal to I2. Then V2B equal to V2. Okay, this is the voltage and current relations. But I want resultant ABCD parameters. A, B, C, D. That we can write V1, V2, I2. That is V2 minus I2. V2 minus I2. Yes, students. But you know this, what is the V1 I1 equal to? This V1 I1 equal to, this V1 I1 equal to, shall I write V1 equal to V1A? This is V1A. How to write this I1 equal to I1A? I1 equal to I1A. This is equal to, what is V1A and I1A? What is the V1A, I1A? This V1A and I1A is, this I am writing. That is AA, BA, CA, DA into V2A minus I2A. Is it correct? V2A minus I2A. Yes. This also equal to, shall I write like this? AA, BA, CA, DA. What is V2A? What is V2A, students? Shall I write V2A equal to V1B? V1B. What is minus I2A? Minus I2A equal to this one, I1B. I1B. Okay. Then this V1 I1 is equal to, finally what I am getting? This AA, BA, CA, DA into, what is V1B I1B? This V1B I1B, shall I write like this? AB, BB, CB, DB. AB, BB, CB, DB into, this I am writing, students, into what you can write? V2B minus I2B. V2B minus I2B. But what is the V2B equal to? V2B equal to V2, I2B equal to I2. Yeah, this is equal to AA, BA, C, not required derivation, just for concept I am giving this. DA into AB, BB, CB, DB into, what is V2B? V2. What is I2B? I2. That is minus I2. Now see, let this is the 1 and this is the 2. Compare 1 and 2. Compare 1 and 2. Then this total is this ABCD. Then what is ABCD parameters in resultant cascade connection? Product of the individual. That is AA, BA, CA, DA into AB, BB, CB, dB. Therefore, this is equal to A T parameters of A network, T parameters of B network. Therefore, resultant T parameters equal to in product of individual T parameters of a network. This is the proof. Just we can multiply this one, then we can get the A, B, C, and D students. Clear? Yeah, this is about the proof. Better. Actually, proof is not required, but finally you remember this one. Yes. This about the resultant T parameters. But even point to remember for T dash note I am giving. For T dash parameters also, for T dash parameters also, for T dash parameters, then resultant T dash parameters equal to, resultant T dash parameters equal to product of, this is the TB dash into TA dash. This is important. Not TA into TB, it is a TB into TA. This is the resultant T dash parameters equal to TB into TA. Okay, this is about cascade connection or tandem connection. Next, series parallel connection. In series parallel connection, which parameters are added directly? H parameters. We can add the H parameters directly. What do you mean by series parallel connection? Input port is series connection. See this one, series connection. This connection is a series. And output port is the parallel connection. Output port is the parallel connection. Then at input port, voltages are added, currents are equal because of series connection. At output port, voltages are equal, but currents are added because of the parallel connection. Because of the parallel connection, voltages are equal, currents are added. Clear, students? Yeah, that is about in series parallel connection. But in series parallel connection, which parameters we can add directly? H parameters. We know that I'm writing V1A for network A. For network A, V1A, V1I2 in terms of I1, V2 is equal to H11A plus H12A, H21A, H22A into V1I2 in terms of I1, V2, I1A, V2A. What about for network B, students? For network B, I'm writing this V1B, I2B is equal to H11B, H12B, H21B, H22B into this is I1 V2A, that is I1B V2B. I1B V2B. Yes. Then resultant H parameters. If you want resultant H parameters, the resultant H, no need of any derivation, directly I'm writing H11, H1. Just by seeing the voltage and current relations only you can derive this one. H21, H22 is equal to H11A plus H12A, H21A, H22A plus H11B, H12B, H21B, H22B. Okay, now add this directly. We can get H11, H12, H21, H22. Then what are the H11 students? H11 equal to H11A plus H11B. What are the H12, H12, H12A plus H12B? Yes, students. Then what is the H21? H21 equal to H21A plus H21B. What the H22? H22A plus H22B. Okay, this is the resultant is the sum of the H parameters, individual H parameters. That is HA plus HB. HA plus HB. Okay, that you remember. Clear, friends? The next one is last one, parallel series connection. For parallel series connection, which parameters added directly? G parameters are added directly. Input port is parallel connection. That's why in parallel input port, that is a parallel series connection. Parallel series connection. The input port is parallel connection. The output port is the series connection. Yes. This is V1 equal to V1A equal to V1B. Please correct this one because parallel connection voltages are equal. V1 equal to V1A equal to V1B. V1 equal to V1A equal to V1B. Voltages are equal. But in parallel connection, currents are added. Output port is series connection. Series connection, voltages are added, currents are equal. Clear? Then in this case also, directly I am writing in parallel series connection, the resultant G parameters. GA, G11, G12, directly I am writing G11, G12, G21, G22. The resultant G parameters equal to G11A, G11B, sorry, G12A, G21A, G22A plus G11B, G12B, G21B, G22B. That is the G parameters added directly. Okay, this is about the interconnection of the two-port networks. Yes, friends, any doubt? This about series connection, series parallel connection, and cascade connection, series parallel, parallel series connection. All these important, please concentrate. Here, very important points mainly concentrate here. For T network, calculation of Z parameters are very easy. But for phi network, the calculation of Y parameters are very easy. Yes, note one, very, very important to solve the problems. To solve the two-port networks problems very easily, all these observations are important, students. For example, if it is a T network is there, not giving derivation not required, even solving of the problems also we can use these results directly. Yes. Let this is the ZA and this is the ZB and this is the ZC. Okay. Then for this network, this is the T network. Then which parameters we can easily calculate? By resultant only we can get this. Okay, which parameters we can easily calculate? Z parameters are easily calculated. Then what is the Z parameters for this one? We can easily calculate the Z parameters. That is ZA plus ZC. This plus this. ZA plus ZC. Then it is ZC. And it is also ZC. And this is ZB plus ZC. ZB plus ZC. That is, this is which parameters? Z parameter. We can easily calculate the Z parameters. Understand, students? That means what is the Z11 here? Z11 equal to ZA plus ZC. What is the Z12 is equal to Z21 equal to ZC. What is the Z22? Z22 equal to ZB plus ZC. Then that is one. For pi network, we can easily calculate the Y parameters. Even impedances are given, you convert into admittances, then do the directly Y parameters. For pi network, which parameters we can easily calculate? Yes, friends. Okay, this is the pi network. If it is YA and this is the YC and this is the YB. I'm not giving the derivations not required because these results we can use directly in solving of the problems. Then how to calculate the Y parameters, that you know, I already explained. That is by making the input port and output ports are short circuited, we can calculate the Y parameters. Then what are the Y parameters here? Very important. This we can write directly, YA plus YC. Students, for pi network, If the impedances are given, you convert into admittance, then you do this one. Don't add the impedances directly. Which one you want to add here? Admittances. Ya plus yc minus yc minus yc. This is yb plus yc. These two. Ya plus yc, yb plus yc. That is y parameters. For pi network, we can easily calculate the y parameters. For pi network, we can easily calculate the y parameters. Okay, this observation is it. That means what is y11 here? Y11 equal to ya plus yc. What is y12 equal to y21? I told already y12 and y21 is always negative. That we are getting here. Minus yc. Then what is y22? Y22 equal to yb plus yc. Yb plus yc. Yes, friends. For example, one more note. If the network is given like this, for this network, yes, if the network is given like this, then we can calculate, for example, if you want to calculate the Z parameters. What are the Z parameters of this network? Calculation of Z parameters are very easy. Why? Because here, assume that it has a T network. Assume it has a T network. If it is assumed as a T network, let this is the here one impedance, here one impedance. But here it is not there. That's why you take the Z equal to 0. This also Z equal to 0. Clear? Then what are the Z parameters? This plus this. 0 plus Z. Z. Then in middle what it is there? Z. This also Z. Next 0 plus Z. Z. Over. These are Z parameters. Because assume it is a T. It is a which one, students? I'm assuming that it is a T network. If it is a T network, means this is impedance is 0. Here impedance is 0. Okay. Now, if it is Z parameters are defined, then what is the Y parameters? Y equal to Z inverse. Y equal to Z inverse. This is not exist. What is the determinant here? Determinant becomes 0. 1 by determinant is infinity. Not exist. That means for this network, which parameters are not exist? Which parameters are not exist, friends? Yes. For this one, Y parameters are not exist. For this one, Y parameters are not exist. Then how to calculate the T parameters? I'm not giving derivation for this one. How to calculate Z parameters, you know. Then the T parameters, how to write for this branch. If only one branch is given, then how to write the T parameters? The T parameters is 1, 0. Very important, students. 1, 0. Because these results we can use to solve the different models of problem. 1 by Z1. Derivations are there, not required. If only one parallel branch is there, 1, 0, 1 by Z, 1 you can write. 1, 0, 1 by Z, 1 you can write. Then how to write the H parameters? How to write the H parameter? Mainly ZY, TH parameters mainly concentrate, not required T dash and the G dash parameters. Then 0, 1, yes, 0, 1, minus 1, 1 by Z you can get. This is the H. Z parameters. For this one, Y parameters are not exist. We can write the T parameters. We can write the H parameters. See, throughout to solve the different models of problems, these results directly you concentrate. Next, one more example. If series branch is given, only one impedance, then you calculate can you define which parameters? Students, let assume that we can easily calculate, for this one we can easily calculate Y parameter, because I'm assuming as a one pi network. Let this is the pi network. This is the pi network. Okay. Pi network, the impedance is infinity. Open circuit means it is infinity. Then impedance is infinity. Impedance is infinity means, but I want admittance. I want to write in terms of admittance. 1 by infinity. This is 0. Sir, how we can calculate y parameter for this one? We can easily calculate because it's a pi network. Then how to calculate admittance 1 by infinity? That is 0. How to calculate admittance y equal to 1 by z? Okay. Now we can easily define which one? Y parameters. Y parameters we can easily calculate. Now tell the students. This one and this one you can add. Y is 0. 0 plus 1 by z. 1 by z. And this is negative of this parameter. Minus 1 by z. Minus 1 by z. 0 plus, you can add the admittances, not the impedances, because I'm calculating the admittance. Yeah, this is completed. For this network, this is completed, sir. Now I'm calculating for this network. Minus 1 by z. 0 plus 1 by z. That is 1 by z. Then we can easily calculate. Then what are the z parameters? Z parameters equal to y inverse. But what the determinant here? 0. 1 by determinant is infinity. Does not exist. For series impedance branch, which parameters are not exist? Z parameters does not exist. For this network, Z parameters are not exist. Then what about the T parameters? The T parameters for this one is very important, students. Even electrical students, even power system transmission analysis also this is useful. T network 1Z01. 1Z01. We can directly write, sir, how we are getting this one? For this one, there is a derivation, but not required. But directly you want to remember these results. 1Z01. 1Z01. It is a T network. Then what is the H parameters? What about the H parameters of this network? The H parameters of this network is Z1 minus 10. Z1 minus 10. Okay, this is about for T network and this is for H parameters. This is T parameters, this Y parameter, this which parameters are not exist? Z parameters are not exist for series branch. Clear, student? Any doubt? Yes. See, for example, I am giving one question. For the network shown in figure, find y22. Find y22. Yeah, this is a given network. For this network, you want to find the y22. This is 1 Henry. This is 2 ohms. This 1 farad. And this is 5 ohms. You find the y22 of the network. The option A, I'm giving options also. S square plus 2s plus 1 by s plus 2. Option B, minus 1 by s plus 2. Option C, yes, s plus 7 by 5 into s plus 2. Option D, s plus 5 by s plus 3. You want to find y22. Option B is not the answer because y22 never be negative. y11 and y22 never be negative. Either y12 and y21 is only the negative. Understand? That's why option B is not the answer. Now, it's just like a pi network. For pi network, we can easily calculate the y parameters. Okay, this is a pi network. No? But these options are given in terms of Laplace transform. That's why for this one, what is the Laplace transform? L into S. Ls. For inductor, Laplace transform is L into S. That is 1 into S. That is how much? Yes. This is for capacitor, what is the Laplace transform? 1 by Cs. 1 by Cs. That is 1 by S. C is 1 farad, 1 into S. That is equal to 1 by S. Okay. This one. I'm talking about the impedances. Okay. Now, this is the impedance. This is the reactance, students. But you want Y parameters mean admittance. Then what is the admittance of this one? Then the admittance we can write this is 1 by s. This is impedance, but you can write as admittance. I want to convert as admittance 1 by s. This is in admittance. Okay. Then this is the impedance, but I want to convert as a admittance. Admittance equal to s. Understand? Now see the students. What the resultant admittance here? The resultant admittance is 1 by 2 plus 1 by s. What the resultant admittance or conductance? That is equal to 1 by 5. What the resultant admittance here? Yes only. But you want which one? Y22. Y22 means we can add these two only. We can add this and this we can add. 1 by 5 plus 1 by 2 plus 1 by s. Is it correct? Yes, friends. Okay, this is how much we can get. 7 by 10 plus 1 by s. 1 by s. 1 by 5 plus, is it correct? 1 by s plus 1 by 2. This is 1 by 5. Say s plus 2. Sorry. First, don't do like this. Total impedance you can calculate, sir. Total impedance you calculate first. Not like this. Just a minute. Okay, this is the total. This is s. This is 2. Then what the total impedance? S plus 2. Total impedance is s plus 2. Then what is the admittance, sir? 1 by s plus 2. This is correct. Now you can do. What the resultant y22? What the resultant y22, students? The resultant y22 equal to 1 by s plus 2 plus 1 by 5. Then what you can get? 5 plus s plus 2 by 5 into s plus 2. Then s plus 7 by 5 into s plus 2. Then what is your answer? S plus 7 by 5 into s plus 2. Option C is correct. First calculate the resultant impedance, then you can do the admittance equal. Don't do individually. Okay, that is wrong. Y equal to 1 by s plus 2. S plus 7 by 5 into s plus 2. Okay, this is the calculation. For pi network, we can easily calculate the, which one, students? Y parameters we can easily calculate. Yes. Please concentrate. Yes. For example, I'm giving one example here. Yes, find the t parameters. Find t parameters. T parameters. Yes. This is admittance that is given in mho. For this network, find the t parameters. Yes, what is your answer? For this network, what is the t parameters? Students, you know this, if it is impedance, then how to write z equal to 1 by y? Okay, then what are the t parameters for this case? I given the formula. What are the t parameters in this case? Yes, friends, just now I given the formula for that, the t parameters. This you see, parallel branch. T parameters 1 0 1 by z 1. 1 0 1 by z 1. 1 0 1 by z 1. But z is 1 by y. 1 0, z is 1 by y, 1. Then what are the t parameters? 1 0 y1. That is the answer. 1 0 y1 is the t parameters. Yes. For example, this is a previous IES question. Find the y parameters. Find the y parameters. It is given like this. This y mo. Directly admittance is given. Directly admittance is given. Find the y parameters. This is in mo. Then for which network you can easily find the y parameters? Pi network. Then this is how much this one, students? This is infinity. Impedance is the infinity, but admittance is the 1 by infinity, that is 0 mo. And this is also 0 mo. Open circuit means impedance is infinity. Open circuit means not admittance is infinity. Impedance is infinity. Then admittance equal to 1 by infinity, that is a 0 mo. Then how to calculate y parameters, that you know. This 0 plus y. This is minus y, 0 plus y. This is the answer. Y minus y, y. Yes, clear, friends? Okay, like this we can calculate the, see, this is the fundamental questions. This minimum knowledge is required to solve the other models of questions. To solve the different models of questions, this minimum knowledge is required. For example, one more example, find the Z parameters. Find the Z parameters of the network. This is the given network. For this network, you want to find the Z parameters. Okay, this is 1 farad. This also 1 farad. And this is 1 Henry. S. Find the Z parameters. But given is which network, students? Pi network. Pi network means which parameters we can find directly? Y parameters. But one method to solve this is first to find the Y parameters. Then inverse of that, we can get the Z parameters. That is one method. Otherwise, you convert star to, this is delta to star connection. Delta to star. Then you can find directly which parameters. Once we can get the star connection, that is a T network we can get. Once we can get the T network, then we can solve directly which parameters? Z parameters. That is another method. Yes. Do that. Here I am giving note. For example, if you want to transfer T to pi transformation and pi to T transformation, this here we want to transfer pi to T transformation. According to pi to T transformation, see for example, this is the pi network. Okay, this is the pi network. This is YC, that this is YA, and this is YB. In terms of admittances, I'm telling. Yes. Or otherwise, direct, because here given is which one, students, impedances are given. Better to convert into, no need of this observation. Directly you can do like this. You can convert into star. Okay, this is 1 by S. This is 1S. That is 1 into S. Yes. This is the S. This also 1 by S. 1 by CS na 1 by S. Okay, 1 by S. You convert into star. Then after converting into star, then you can get the network like this. You draw the network like this. Then for this network, find the Z. How to convert the star, that you know. Find the Z parameters. This I am giving assignment for you. Try this. Yes. Yes, one more problem. The next topic is, before going to the conversion of the parameters, you concentrate on different models of problems. See, for example, yes, for the network shown in figure, for the network shown in figure, find T parameters. Find T parameters. Okay, this is the given network. This is the 2 ohms. And this is 2 farad. And this is 2 Henry. Yes, know this. 2 ohms, 2 farad, and 2 Henry. See, one of the best method is to solve this T parameters, because you know the for one branch, for series branch and parallel branch, you know, that's why I'm dividing like this. In a T parameters, let this is one network. It is a cascade connection. This is another network, and this is the another network. For this, we calculate, let this is the TA, this is the TB, and this is the TC, because the cascade connection. In cascade connection, which parameters we can add? We can multiply directly T parameters. That's why it is also T parameters are asked, no problem. Then what is the TA? Yes, what is TA, students? You know, for this branch, 1Z01, 1Z01. That is 1201 over. What is the TB? This is parallel branch. This is what is the impedance of this one? 1 by CS, 1 by 2S, 1 by 2S. Then for this, what is the Z parameters? If it is a parallel branch, is there 1 0 1 0 1 by Z1? This is correct. 1 1 0 1 by Z1, 1 0 1 by Z, 1 by 2S, 1 by 1 by 2S, that 2S 1. This is a TB. What is TC? What is the impedance of this one? 2S. Impedance of this one is 2S. This is 1Z01. 1Z01. Then what is the Z here? 2S. 1, 2S, 0. Clear? Then what are the resultant T parameters? The resultant T parameters equal to TA into TB into TC because the cascade connection. Then multiply all these. 1, 2, 0, 1. Next 1, 0, 2S1. Next 1, 2S, 0, 1. 1, 2S, 0, 1. 1, 2, 0, 1. 1, 0, 2S1. 1, 2S, 0, 1. Then first multiply these two matrix. Then you multiply this resultant with this matrix. All of you know how to make the matrix multiplication. Directly I am writing 4S plus 1 you can get 2 into 4S square plus S plus 1 you can get. Then 2S we can get 4S square plus 1 we can get. Just multiplication. First multiply these two and you multiply this resultant with this matrix. Then these are the ABCD parameters. These are the ABCD parameters. Then what is A equal to? 4S plus 1. What the B equal to? 2 into 4S square plus S plus 1. What the C equal to? 2S. What the D equal to? 4S square plus 1. Okay, this is the calculation of ABCD parameter. Because in cascade, instead of doing the analysis, if you want to calculate the ABCD parameters, is one analysis is make the I already explained how to calculate the ABCD parameter, open circuit and short circuit like that. Okay, but not required that one. This concept you already know. In the case of cascade connection, T parameters are directly multiplied. For this simple case, if only one branch is present, one series branch, one parallel branch, one series branch, how to write the T parameters, directly I explained. Then use that concept, solve for this one. Clear, friends? This is the calculation of T parameters. Yes. Yes. And one more note you remember, this note also important for T parameters. Yes. Yes, later on that I will give. Later on I will explain in the conversion process that I will explain, not required here. Yes, students, still different models of questions are there. See, for example, this is a gate question. Here I am giving. Let's try this one. If Zn equal to 1, 2, 3, 4 ohms. 1, 2, 3, 4 ohms. The total Z parameters are the total Z parameters Z of the network is dash. Okay, this is the given network. This is 1 dash, 2 dash. Okay. Now this is input port. Input port is series connection. Output port is also series connection. This is the series connection. Given is series connection. Series connection. In series connection, which parameters we can add directly? Z parameters. For this network, Z parameters are given. For this parameter, for this network, what are the Z parameters it is given? 1, 2, 3, 4 it is given. Then what is the Z parameters of this network? Let this is ZNB. Then it is given is T. This is how much it is given. This value is given 1 ohm, and this is the 2 ohms. But here it is shorted means it is a 0 ohms. Okay. Given is T network, we can easily calculate the Z parameters. 1 plus 2, 3. This is 2. This is also 2. 2 plus 0, 2. Then what are the resultant Z parameters? The resultant Z parameters equal to Zn plus one more network. I am assuming that Znv. What is the Zn? 1, 2, 3, 4. What is Znb? 3, 2, 3, 2, 2, 2. Add directly. What you can get, students? 4, 4, 5, 6. Okay, these are the Z parameters of the resultant network. Clear? Understand? Because the series connection. Input port is series connection, output port also is. This network parameters directly given. But this network parameter I calculated. Sir, how you calculated, sir? This is a T network. In T network, calculation of Z parameters are very easy. Add these two. Select this here and select this here. Then add these two again. Then 2 plus these 2 you can add. 0 plus 2. That you can get the 2. Any doubt? Yes, friends? Say, for example, one more. This also gate question. Find Y parameters of the network shown in figure. Find Y of the network shown in figure. Okay, this is the given network. Okay, this is 1 ohm. This is also 1 ohm. And this is 1 ohm. And this 1 farad. Okay, this is the given is parallel connection. Parallel connection. Given is parallel connection. In which parameters added directly? Y parameter. Because input port is parallel connection, output port also parallel connection. Then which parameters? Y parameter. Let's consider one network. This is one network. Okay, this is the one network. Let this is network A. 1 ohm, 1 ohm, 1 ohm. For this one, we want to find the y parameters. First, we find the z parameters. We can easily find the z parameters. 1 plus 1, 2, 1, 1, 2. Then if you want to find y parameters, inverse of that. Then what is the inverse of this? Determinant is 2, 4, 4 minus 1, 3. 1 by 3. Determinant is 1 by 3. D minus B minus C A. D minus B. D minus B minus C A. Okay, that what is we are getting here? Y parameters of network. One network 2 by 3 minus 1 by 3 minus 1 by 3 2 by 3. Okay. Let this is one network. Network A. Let us assume that network A. What is the another network it is given? Network B. What is the you want to find the ZB? This is the network B. The network B is 1 farad. Okay, this is 1 farad. What is the impedance we can write? 1 by CS, 1 by S. This is the impedance. But how much admittance we can write? The admittance equal to S. Because it is a pi network, we can frame as a pi network. We can easily find. Because this is the impedance is infinity. Then what is the admittance? Admittance equal to 1 by infinity. That is 0. That is Y also 0. Then we can easily find the admittance matrix. YB. S 0 plus S. S minus S minus S 0 plus S. Yes. Clear? Now what is the resultant admittance matrix? The resultant admittance matrix is YA plus YB. What is YA? 2 by 3 minus 1 by 3 minus 1 by 3 2 by 3. What is YB? S minus S minus S. Yes. Clear, friends? Then add all these. Then what you can get? S plus 2 by 3 minus S minus 1 by 3 minus S minus 1 by 3 S plus 2 by 3. Clear? Okay, like this we can calculate the Y parameters. Here the two networks are given. This is one network and this is another network. These are the parallel connection. Parallel connection, which parameters we can add directly? Y parameter, because it is also Y parameters itself. That's why problem is very easy. Then for this case, finding the Z parameters are very easy. I inverse that one. I got the Y parameters. For this case, finding the Y parameters directly, very easy. Then Y equal to YA plus YB. Clear? Yes, friends. This is about today's session. Remaining whatever the concepts are there with respect to two port networks. I will tomorrow session I will solve some problems, continuation of this. Then I will finish that remaining concepts also. Mainly, one topic is conversion of parameters. How to convert one parameter to another parameter. Then final is image parameters. Image parameter. That two concepts are there. The remaining is completed. Yes, friends. Is it okay? Thank you. I'm ending the session. Yes, friends. Thank you.